ఇలాంటి చాలా ఉన్నాయి ఇంకా దాచాం.
Hi guys, welcome back. I think in the previous session you guys have asked for transients. So let's try to solve some transients questions from network analysis. So today I'm here with transients questions because in the last live session itself I promised that okay, I'll come with transients in this session. So here we are. So I come up with some interesting questions. Obviously the basics only. We're not going to get deeper, much deeper, but yeah, basic level. Yet we're going to build some concepts with the help of those basics. Okay, let me quickly roll through the questions what we're going to see now. So I'm just quickly taking you through the questions. Yeah, this is a good question, really good question, and yeah, these are normal. Yep, this one also an interesting one. Okay, so I'm just hovering through the questions, question paper. If you just have a look, this is also a good one. It's okay. Normal one, good one. This is a good one. I mean, I'll give you easy tips to solve these kind of questions. Without, you have a lot of equations over here, but without actually getting into the full equation, we should be able to mark the option. Okay, because time is a key aspect here, right? And yeah, I think more. Yes, we do have. These also interesting one. And the next question, yes, this is also a good one. So these questions we'll see in a simplest possible way how to handle this, because time is a key aspect when you're attempting, of course, a gate exam. You'll have plenty of time. Actually, yes, gate exam is not a speed time, it's accuracy exam. Okay, it's not a speed exam. But apart from a gate exam, if you appear any state government or central government exams, they are accuracy, of course, but mainly speed is a priority. Okay, so you have to give priority to the speed, at the same time accuracy. Okay, so when you are pushing up the speed, when you're trying to ramp up the speed, accuracy normally comes down. That's what somebody said. Speed and accuracy are inversely proportional. Okay, so when you're trying to increase the speed, accuracy will come down. Okay, so yeah, now we will try to see in a smallest possible time how to handle those questions, how to answer those questions. We'll see that. Let's start with the first question. This is the first one. Okay, so I recommend you to try. You know the drill. You have to appear the question in a minute. Check करेंगे. Okay, okay. Yeah, we're starting off with a simple question. Okay, hopefully everybody is right. Let's see. For this question also only couple of very less answers. I don't know why. Don't give the formula, dear. Come on. Don't give the formula. Everybody knows the formula. Now the here objective is to see how quickly you're answering it. Okay, so you have to give the answer as well. Anyways, time's up. So we got mixed answers, but yeah, most of the people are saying A is the answer. Let's see what's the answer. A series RC circuit has a time constant of 0.1 second. Yes, absolutely right. Sampath has given the formula. Tau is equal to R into C. Now the key point here, guys. If you remember this, for RC circuit, time constant is RC. What is there to remember? It's easy to remember. Time constant for RC circuit is RC. That's it. Now time constant for RL circuit is something very easy to remember. RC circuit and RL circuit, they are dual to each other. What is the duality concept? In place of C, place L. In place of R, place 1 by R. So into 1 by R, that is L by R. So for RC circuit is RC only. For RL circuit, don't try to remember, just think it as duality. They are dual to each other. Okay, if you apply duality concept in place of R, 1 by R, in place of C, L, that's it. That's a duality concept. Okay, so isn't it amazing? So this is for RL circuit. Anyways, it's for RC circuit. Now tau value is given as 0.1 second and the C value is given as micro. You know, guys, you need to be focused on these micro, milli, nano, pico, all this stuff. Okay, so this is 2 microfarad. Okay, so once this 2 comes here, you need to find R. 2 comes here, it's a mega, so this is wrong. Okay, mega, and this 2 goes here by 2, which is half of this, just half of this. 0.1 half is not definitely 0.1, not even this. So answer is this, 0.05. Easy. I think most of you guys have marked it right. Okay, but Gautam, I think you must have misinterpreted the question maybe. On what basis? I think you missed this micro. You should be careful with the units. That's what I've been saying all the time. Units, if you pay attention, then most of the times you'll get the right answer. Okay. Normally people do not pay attention on the units, which are very important. Sometimes if you may not know the formula, but with the help of units, you can land up in creating the formula. With the help of units, you can get the answer. Yes, pretty much do that. Okay. Anyways, moving on to the next question. This is also easy one. So I think you won't be having any issue on this. Quick. Good. So we got a quick response because this is also a matter of speed as well. Okay, though 1 minute timer is running, you should not wait for 1 minute. You should be as quick as possible. Okay. At the same time, accuracy. Okay, don't miss accuracy at a cost of speed. When you are appearing for speed, when you are trying for speed, if it is a wrong answer, if you're marking wrong answer, that's ridiculous. Okay. Everybody is one way, Gautam is another way. Sai Ganesh, Gautam Chenchula, I mean, because we got 2 Gautams, Gautam Das as well as Gautam Chenchula. So we got a mixed answers for this. I don't know why. This is, easy one. Yet you got mixed answers. What happened? That's not quite expected. People are giving mixed options like A, B, C, D. Every option is touched almost. What happened, folks? A capacitor C acts as, see, simple question. Yet you marked it wrong, some of you. Okay. I mean, that's not acceptable. Capacitor C at t is equal to 0 plus. Initial charge is there. Initial charge is there. Means at t is equal to 0 minus, it has a charge of Q naught. Means it has a voltage of V naught. Some voltage is there at t is equal to 0 minus. Immediately at t is equal to 0 plus, there won't be sudden change in charge. No sudden change in charge. Hence, no sudden change in voltage. So at t is equal to 0 plus also, the capacitor voltage will be same. See, don't start your analysis from the voltage. Start your analysis from the charge. Okay, it is storing the energy in terms of charge. No sudden change in charge is possible. Hence, naturally, Q is equal to C into V. C is anyways a constant after all, right? So if no sudden change in charge, there won't be a change in voltage. Okay, so voltage is same even after the switching action. So it will act as a voltage source. Okay, it is just talking about t is equal to 0 plus instant, at that instant only. Okay, and you're right, only capacitor, if it is just a capacitor, that capacitor will act as a short circuit. Capacitor is there, that capacitor will act as a short circuit. But now that capacitor is having some initial charge, so you need to represent there is a short circuit, and the initial charge whatever is there, that also you're representing it as V naught, and this is a complete representation of a capacitor under a transient state. It is equal to 0 plus state is a transient state. Okay, so it is just like a voltage source of value V naught. So answer is D. Okay, I think any confusion on this? Any confusion on this? Shall we go further? Respond on the chat quick. Quick. Let's see how many of you are going to answer this. This is an interesting one. I want everybody to respond. Everyone to respond for this particular question. This is an amazing piece of question. Those who gave the answer already, if it is possible, try to give your analysis. What do you think, why that option is right? If there is scope for you to type, just give it a try so that others will also understand. Sampath, you retracted, deleted your question, your option. Why? I think you realized your mistake, maybe. Is it because everybody is marking something else? That's why you deleted it, or you realized it? So what's up, guys? F D. Voltage should not be, voltage source should not be short circuited. So resistor is saying voltage source should not be short circuited. Why? Who is short circuiting the voltage source? Nobody is doing that. Anyways, time's up. We got low responses for this. I don't know what happened to the others. What you guys are doing? Try to participate. Check it. How far you're knowing the concepts. Nobody is going to blame you if you're wrong, right? You're going to check yourself whether you're right or wrong. That's it. What's the harm in marking options? You just have to pump one number. Press one button. That's it, right? Yeah. Okay. Now, referring to the circuits of figure 1 and figure 2, which of the following statement is, or whatever, with respect to the voltage V in the figures is correct? Okay, which one is correct? You got a voltage source here. This is a capacitor. This is a current source. This is a capacitor. You know the symbols. They don't have to mention it is a voltage source V. This is a capacitor C. Its symbols are representing definitely the same. Okay, explicitly one doesn't have to mention it. Okay, this is I, this is C. So it is said with respect to voltage V, circuit 1 is stable, circuit 2 is unstable. Both the circuits are stable. What does stable means? It's just a mixture of your control systems kind of a thing, as well as networks. How nicely they blend these two, see, in this beautiful simple question. Here you can say this voltage is always constant as supply voltage. Am I right? This voltage is always same as supply voltage. Here the voltage will be same as this voltage. So this voltage is constant. Figure 1 voltage is constant. This is a voltage V because it is constant with respect to V. Now for figure 2, can somebody tell me what's a voltage shape with respect to time, how the voltage is going to be? With respect to time, I'm plotting here. Okay. So how will this voltage be with respect to time? Yeah. So Srinivas is trying to answer for somebody, I think. You can check it. Yes, linearly rising, ramp. It's slowly ramping up. It is like this, like this, like this, like this, like this, like this. Voltage is continuously increasing. Now from control systems, is this a stable response? Definitely unstable. Definitely unstable response. This is not stable. So figure 2 is unstable and figure 1 is stable. So this option is absolutely correct. Absolutely correct. That's it. See how nicely they made this, they framed this question. Okay, I hope. Let's blast for this question itself. Okay, so for the question. Anyways, let's move to the next one. Okay, if you're ready, we're moving to the next. Try answering this. Capacitor allows change in current. Yes, that's true. It's not about changing current or anything. It's not about changing current. The question was all about, because Nagdeep is saying capacitor allows sudden change in currents. Yes, that's true. Nobody is denying that. It is unstable because voltage is ramping up. I think it's clear, Nagdeep. So everybody answered. Emmanuel has answered as increasing yes, for the previous one. Okay. Straight line. Yeah, true. Okay, time's up. I don't know, for this question, very less responses. How come, huh? That's strange, right? You got a minute time at Ashwini, Sai Ganesh, Nagdeep, Nelson. Nelson. Nelson means jailer movie director, I think, Nelson. Okay. Let's, oops. Okay, anyways, let's stop this because time's up. You took a lot of time. In the given RC circuit, the current reaches its maximum value. Current reaches its maximum value. When this will be maximum? Simple RC circuit is given for you. You guys don't even know current response of simple RC circuit under transient. See how strange the things are happening, and you want a job. Huh? You want a job, but you don't know what's a simple basic RC circuit response, current response. How is the current response? Current response will be, look at this. Current response for this RC circuit when switch is closed, okay, so this will be short circuited. So maximum current and slowly current will reduce, slowly current will reduce, and when t is equal to infinity, current will be 0. So it is asked for maximum current. So immediately after turning on the switch, current will be maximum. These questions are the previous year questions of Andhra Pradesh, Karnataka, Telangana, state electricity boards, along with ISRO. Okay, these are the previous year questions. And you guys are like very crazy. Such simple questions you're unable to answer, and you want a notification to be released as soon as possible. What you'll do once notification is released today itself? What you'll do? You'll cry. Sir, I don't have time to prepare. I don't have time to prepare. I don't have time to. Now you are crying for a notification. Once notification is out, you'll cry for time. Always you love to cry, I think. Anyways, we got some interesting comments. Sai Ganesh is saying in steady state capacitor act as open circuit at steady state. That's true. So current will be zero. That's what it says. In zero here, current is zero. Okay. Exponential decay, Srinivas, absolutely right. Absolutely right. Okay. Sampath, current allows sudden change in current. That's fine. That's fine. Not a problem. Okay. From zero, suddenly current is when switch is closed. Before switch is closed, current is zero here. The moment switch is closed, current is suddenly raised to the maximum. Yes. But according to the question, it is asked for what's the maximum value of the current immediately when this is there. I think this is pretty much clear. I'm moving to the next one. Next question. Yeah. This is ISRO question. Okay. And we got some TSGENCO 2015 questions also. Okay. TSGENCO 2015, that's what the previously notified notification. Okay. So for that also we got some questions from transients. Let's see how you will catch up those. Wow. I don't know whether it is right or wrong, but everybody is giving option C. Now Emmanuel has said option C. Yes, it is also there. AP EPDCL questions also there in this. Okay. Anyways, good response. At least some people have responded. Others, anyways, they just like to see. They are seeing it. Okay. Okay, cool. Time's up. We can't wait for so long. As timer is running, we only wait as long as timer is running. Okay. Let's just look at the analysis because we got a lot of other interesting questions as well. In the series RL circuit shown below, wow, simple series RL circuit. The switch is closed at t is equal to 0. Okay, earlier switch is open at t is equal to 0, switch is closed. The value of current at t is equal to 0 it is asked. Okay. So we know this is this current. Current means current here, no current is symbolized here, no current is given here. So which current you will take? Definitely you will take the current flowing through the inductor. Okay. So because I can't change the question. The question is as it is from the ISRO paper, so I just kept it here. Okay. So you have to take it as current flowing through the inductor he's trying to ask. Now we know from the basics, IL0 minus is equal to IL0 plus, which is equal to IL0. Okay. At 0 minus whatever current is there, at 0 plus also same current will be there. Even at 0 also same current will be there. 0 means at t is equal to 0. Okay. And we know that's t is equal to 0 minus, t is equal to 0 minus. Tell me the circuit is under steady state or transient state? Yes, now I want everybody to respond. I want everybody to respond. Huh? T is equal to 0 minus, is that circuit under steady state or transient state? Yes, absolutely. Tritish has said quickly, which is steady state. Okay, at steady state, this will act as a short circuit. This will act as a short circuit. Means there will be some current flowing through this. It's not current is 0. So option A is wrong. Whoever is saying option A, that's a blunder. Okay, first thing to mark wrong is option A. Now, next one, careful here. I think somebody has said 2 ampere, 2 ampere. Emmanuel, everybody started saying 2 ampere. That is also wrong. That is also wrong. Okay, I'll tell you why it is wrong. In such a terrible situation you are. You need to improve. You need to learn first. Improve means what? Not just by watching a practice session. First learning, prepare first, then practice. Plan, prepare, practice. Plan, prepare, practice. That's what PiSquare policy. Okay, PiSquare policy is P for plan, P for prepare, then P for practice. Okay, so anyways, IL0 minus, all of you, including Emmanuel and who else? Who else? Resistor. Resistor. What's the name, by the way, resistor? Your name itself is resistor. Or ohm. George Ohm as well as Emmanuel. Tell me, IL0 minus, what's the value of current? IL0 minus, what's the value of current? Srinivas has given elaborative explanation. Those who want to see, they can have a look. Yeah, I want Emmanuel as well as George Ohm, who is there live right now. I want you to respond for what's the value of IL0 minus? What's the current? Which is 10 by 7 ampere. And it is clearly written IL0 plus is also 10 by 7. IL0 value also 10 by 7. So answer is 10 by 7. Such a simple question. Anyways, now you got a clarity. It's okay. Doing mistakes when you're learning is alright. But once you're in the exam, no mistake. Okay. Great. Let's go to the next one. Next question. Easy one. I think everybody should be able to answer this one at least. Huh? Everyone can answer this. This is also previous state electricity question, state electricity board. Just now we discussed for RC circuit it is RC, for RL circuit duality concept, L by R. Somebody tell me what's the value of, what's the unit for this L by R? What is the unit for this L by R? Tell me. Sharat Chandra, if you are marking D, in a same line when you're marking, we won't recognize that. If you want to give D multiple times, D enter, send that way. I want yes. Very good. Everybody said it right. Now my question is, if the units is seconds, means it's a time. Then why you're calling this one as a constant, time constant? I hope you got my question. The question is, it is a time, it is having a unit second, so it is a time. Why you are appending a term constant to this time? According to the formula, no unit. Why no unit? L by R, L is not ohms. Okay, L is Henry by ohm. Okay, so it is having a unit seconds. Okay, if it is XL by R, you can say it's unitless. It is L by R. Okay, and the question is, somebody say time constant. Why that name constant? Let's do one thing. Let's take up a call. Okay, those who will answer this question, they will get flat 25% discount on the course. Whatever the course you want, will give you 25% discount. Okay, so you need to call right now in the live, just now. You make a call to us. You know the number, right? You know the number? Number is 99899 39982. Okay, phone will be up. Yeah. Anybody? I'll wait for maybe one more Just a minute, I'll wait for the call. Otherwise, we'll go. His number is right? Fine. Number is right. Let's open the call. You got 40 seconds more. Already courses are at best price. On top of that, you're getting extra discount of 25%. Those who can answer this, why this constant? Why this Kolavardi? Huh? No call it. Means nobody knows that. Nobody's even trying. Offer expires in 10 seconds. Yes, we got a caller. We got a caller. Let's take up the call. He's on speaker. Hello. Uh, Dear, you need to mute your, YouTube session. Just talk to me on the phone line. Yeah, please tell me why the name constant is given for this. Yeah, be louder so that everybody will listen. We lost him. Let me try calling him. He's not taking the call. So I think you guys, nobody has tried. So, anyways, now try. Don't try to call. I'm not going to pick. The phone is with me right now. We're not going to pick the call. Your time's up. Okay. Time taken to elements get 36% of final value, damping ratio. My question is very specific. What's my question? My question is why this term constant I'm including here? Very precise question I'm asking. Okay. Do one thing. That's why I'm saying, guys, you are not studying, you're not preparing, you're worrying, you're not a warrior, you're a warrior. Warrior, there is a difference. You're a warrior. Okay. Learn first, then cry for opportunity. Without learning, if you cry for opportunity, you will be dead in the process of cracking it. Okay. You're not going to succeed. First, get that caliber. Without getting the caliber, if you jump into the war to fight against somebody, you will be dead naturally. It's a simple logic. If you want to survive in the war, you need to get some skill first. Be in the process of acquiring the skill before jumping into the war. Yes, treat this as a war. You are entering into a war zone, competition. You need to win that war. First, to jump into the war, don't cry once you jump into the war, definitely you'll be dead. Somebody will kill you. Somebody will surpass you because you're not prepared enough. These simple things, if you're not able to say, because the value is a constant value. Yes, that's true. I think with his line itself, I can interpret he knows the answer, but because of maybe typing issues, I think he's unable to say. Raju, if you want to speak up, you can call. Call is open for you now. Okay, so that others will listen. Your answer, Raju, just for you. If you want to open, if you want to call, I'll wait for 10 more seconds. Because yes, he makes some sense. His line makes some sense. Okay, I think Raji is also not trying to call, or maybe line is not getting connected. I'm not sure. What's the problem? Okay. Anyways, So yes, that's true. Its value is constant irrespective of the voltage what you are giving. It depends on circuit parameters only. What's the initial value, what's the final value, what's the circuit, what's the voltage, what's the current flowing, doesn't really matter. Okay, its value is always constant. And time constant definition wise, if somebody asks you the definition of time constant, Nagdeep is saying, sorry Nagdeep, this definition is absolutely wrong. Okay, this definition what you're saying is absolutely wrong. Don't say, sir, if it is not 36%, it is 63%. Just take it reverse, you say that that's also wrong. Come on, don't say that. Okay, both are wrong. And it's not that, don't get offended, Nagdeep. It's not that only you say this. Everybody talk about this only. When somebody asks what is the time constant, it is the time taken to 36%, blah, 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 blah. That's it. That's wrong. Or maybe 63%, 63.7%, e power minus 1, all this stuff. Not right. Yes, not right. Okay. Again, Raju is answering it. Raju has answered it. This is what the answer. And Sanjeev is trying to say something. With initial rate of charge constant throughout the operation, circuit will reach at one time constant. Wow. Sanjeev, you're 100% right. You are 100% right. You're not sure, but you're right. Okay. And this is what exactly we're trying to teach you, the root cause in the courses. Okay, in the course, not only in our course necessarily, if you pay attention on anybody's course, be it a free course or a paid course, content will be the same. Okay, your attention should be there, that's it. Okay, and people started asking nowadays a lot of questions like, sir, I'm preparing for GATE exam. So another exam, TSGENCO or GENCO, Transco, these exams, okay, DISCOM exams. How to manage these? What, how to manage this? How to study these? What, how to study this? Simple point. Here, Ohm's law, KVL, KCL, some Ohm's law, some KVL, KCL. Here also same Ohm's law, here also same Ohm's law, irrespective of your exam, Ohm's law is same, KCL is same, KVL is same. Now only concern is, if you are preparing for GATE level, much deeper level you will go. Numericals will handle mostly, along with the concepts. But if it is this exam, when you are preparing for other exams, you need to see the surface level as well. Not only the deeper level. You need to see the surface level also. Okay. So when you are preparing for GATE, anyways you are diving down to the deeper. When you're diving down to the deeper, you can also see the surface, right? Naturally. And pay a little more attention. Be cautious in the surface level concepts also. Okay, and try to expect some easy questions as well, like 1 mark questions. There is no separate thing when you are preparing for GATE. Maybe, suppose when you are preparing for TSGENCO, any GENCO, any Transco, any DISCOM, anything, subject is a key thing, right? Level is BTech level, only undergraduate exams only writing, or diploma level exams you're writing. When you're writing undergraduate exam level, questions will be, content concept will be pretty much similar. Okay. Now when you're preparing for this, suppose you want to appear GATE exam, then when you're preparing for these, go deeper, a little more deeper, you dive down a little deeper, then you will be able to attempt GATE questions also. As simple as that. There is no Ohm's law. Ohm's law is same in all the cases. Thevenin's theorem is same in all the cases. Norton's theorem, transients case is, in case of time constant, definition is same in all exams. You guys are not actually focusing on a preparation. Your objective should be not cracking the exam. I always say this to my students. Crack the subject first. Okay. Anyways. Sampath, how fast it is charging and how fast it is discharging. Yes, you're also right. That's also one of the correct statements. Anyways, let's now get into the next question. We got a lot more questions, by the way, so let's quickly go to the next one. Sanjeev, for this answer, what do I? Yeah, this is just for you for the answer, elaborative answer, as well as Raju is also correct. Okay, Raju is also correct. Oh, this is SPDCL question, I think he is saying. Okay. A circuit with 2 ohm, your time's up, so that's why I'm moving on. And for this, wow, that's good to see all are marking option A. Okay, good. Let's see if it is right. A circuit with 2 ohm, L is 1 Henry is excited by a step voltage of 10 volts at T is equal to 0. It's a RL circuit. The current at T is equal to 10 seconds. So what's the time constant of this? Time constant tau is equal to L by R, which is 1 by 2, which is 0.5 seconds. Okay, it is asked for 10 seconds. From 0 seconds to 5 times of this 0.5, which is from 0 seconds to 2.5 seconds, you will consider this one as a transient state. Okay. Beyond this, we'll almost take it as a steady state, almost reach to steady state value. So he is trying to ask a question. What is the current flowing through the inductor or in the circuit at a steady state? 10 seconds means you can pretty much interpret it as steady state. Okay. So steady state inductor will act as a short circuit, voltage is 10 volts, resistance is 2 ohm, 10 by 2 which is 5 ampere. So all of you are right. All of you are absolutely right. Okay. Anyways, let's get to the next question. Yeah, this is also easy one. I think you'll be able to answer it quickly. We got a quick answer from Sanjeev, Sampath, Raju, Tritesh. Everybody marked C. That's a good sign once again. Emmanuel, nice. Wow. Sai Ganesh has given an elaborative explanation. Let's see, your time's up by the way. So let's just, which of the following has the quantities dimensionally different? L by R, you know this is time constant seconds, this is also seconds. This is no units. Tell me what is this omega L by R represents one factor. What is that factor? Omega L by R represents one factor. I want to know what is that factor. Absolutely right. This is quality factor. Nagdeep. Nagdeep is first. Sanjeev is next. which has no unit. And this 2 pi by omega, this is also unit seconds. Okay, so this is different, so answer is C. That's it. So you guys rocked it. Next one. Oh, Tritish is also said in a smarter way. Simply Q. Good. Srinivas, Emmanuel. Nice. It's good to be smarter like this. Okay. Some people call it lazy, but yeah, it is smart. What happened to this? What are you guys doing? Do it fast, quick. Quick, quick, quick. I'm not getting enough energy today because you guys are not participating enough. I think you guys might be zoned out. I don't know what's the reason, or you're not able to make up those questions. So I think we'll end this live with maybe 2 more questions. Okay, we got actually 20 questions, but I see very less participation. So at 15, we'll wind up the session. Okay, we got 4 more. What to do? Ha, time's up, by the way. So everybody answered almost. Option C. Okay, that's a good one. Let's see whether it is right or wrong. I read the following statement P and Q. Pick up the correct option. P statement is an inductor acts as short circuit to DC. Yes, that's true. The statement is true. The current through a capacitor cannot change abruptly. No, it will change abruptly. People have been saying all this, a lot of comments we got previously. Inductor current cannot change. Inductor voltage can change abruptly. Similarly, capacitor case, current can change abruptly, but not the voltage. So this statement is wrong because it is talking about a capacitor current. It can change abruptly. So only statement P is correct. Wow. Most of you are right. Okay. Except one person. That's okay. I think he's learning maybe. Okay. Let's go to the next question. Handle this. Tomorrow, frequency response in control system. That's what the call for tomorrow. When you're picking the tough concepts, people are not participating. I think it's better to do rather than live session, recorded sessions. If you publish it, that's much better because I expect interaction during live sessions. Okay, when you're talking about these frequency response, all these things, people will just see like that. Look at the transients. Today now, nobody is responding, right? We're even abruptly blocking the session. Okay, stopping the session. So I think for live, these are not maybe the right topics, transients all, because people have very less knowledge on these transients. Okay, and they won't try to even build their concepts also. Okay, time's up. Time's up. Wow, everybody option is only one, which is option B. Mostly people are opting for B. Good, very good. Okay, fine. A unit step voltage is applied at t is equal to 0 plus to a series RL circuit with 0 initial conditions. Okay, series RL circuit, you're applying a step voltage. See, there is a difference between a DC voltage and step voltage. Okay. So no initial conditions. Then RL circuit is a first order circuit. Control systems concept, if you apply, RL circuit is a first order circuit. In a first order circuit, you will never get oscillatory response. It has to be second order. Then there is a possibility that you will get oscillations. Okay. So first order, there is no chance of getting oscillatory response. The next question is very interesting. Okay. The voltage across the resistor at T is equal to 0 plus is 0. Yes, because initially relaxed circuit, then IL of 0 minus is equal to 0, which is equal to IL of 0 plus is also equal to 0. When there is no current flowing through the inductor, means there is no current flowing through the resistor. When there is no current flowing through the resistor, there won't be any voltage across the resistor. So this statement is absolutely right. The energy stored in inductor is steady state. No, at steady state there will be an energy stored as half Li square formula. A resistor current eventually falls to 0. No, resistor current will eventually increase to the maximum. Okay, so answer is B. Next one. Easy one. Wow. Mahendra is proudly saying, no pen paper, option is B. That's a confidence. I like the confidence, buddy. Okay. All these questions, we never did that. You should be able to answer. You will get few more questions next in series. Okay, in the next you got few more interesting questions. There you may feel like you have to put pen and paper, you have to use pen and paper, but without them also you can answer. Okay, that's a good confidence, Mahinda. Let's see whether it is right or wrong. Okay, so we would mark for B. I think B should be possibly right. Some people are saying A as well. Okay, time's up. Srinivas is saying exact year and which paper is this? That's good. The switch in the circuit has been closed for a long time. Okay, switch is closed for a long time. It is opened at T is equal to 0. The current through the 1 microfarad capacitor. What's the current flowing through this one switch is open? When switch is closed, this is a 5 volts total. So this 5 volts will be current flowing is 1 ampere, or simply if you apply voltage division, believe me guys, for transients, to understand transients well, keep this point in your mind. You need to be clear with the voltage division, you need to be clear with the current division, and finding resistance. If these points are clear, transients topic will be very easy for you. Most of the people get confused, most of the people get trapped in the transients just because of they're not clear with these. Believe me, if you are clear with these, 100% clear with these, it will take just maybe half an hour to master a transient, at least level 1 questions. You will be able to answer 100% of level 1 questions in the transients if you master voltage division, current division, and resistance, equivalent resistance calculation. Okay. So according to voltage division, 5 volts, 1 volt here, 4 volt here. So this voltage, when switch is closed, it is charged to 4 volts. Now, when switch is open, this 4 volts will drive some current through this 4 ampere. Now what is that current? 4 volt, 4 ohm, 1 ampere current. Okay, absolutely right. Absolutely right. Okay, So let's go to the next question. So as I said, 15th question is going to be the last one of today's session because of poor participation from your end. We already got the answer from Srinivas. Srini is very quick. Good. Resistor, Mr. Resistor, you said 4 seconds, but you typed it as a 4. Our system has taken it as option D. Okay, that's an interesting one. So it's better you give ABCDs. Okay, or maybe 1, 2, 3, 4, not the value. Sometimes this also happens, this will also trick your mind. In the options, they will give it like this. Okay, 1, 2, 3, 4, or the suppose 4 options you have 1, 2, 3, 4 like this. You need to bubble 1, 2, 3, 4. And you got a number which is 3 ohms and 4 ohm, 2 ohm, 1 ohm like this. These are the answers. Now you got, when you're calculating, you got answer as a 3 ohms. What you'll do is you will bubble this 3, option 3 you will bubble, which is absolutely wrong. Okay, so you need to be careful with what is asked. Always be careful. Okay, anyways, coming back to this particular question. Time constant of this circuit, simple circuit here. You got a current source, open circuit the current source, deactivate the current source. The circuit is deactivated. Now draw a line, separating line the resistors and capacitors. These two are in series, which is 6 ohm. These two are in parallel. This is a 2 farad or 0.5 farad. It's 2 farad. Capacitor farad values are in parallel, it is added. This 2 farad and 1 farad, they are in series. So C1, C2 by C1 plus C2 for series. So it is a 2 by 3 farad. Okay. So time constant formula, tau is equal to R into C for RC circuit. R value is 6. It is 2 by 3. 3 here 2 times. 4 seconds. Absolutely right. Absolutely right. You're not clear about your answer? You said 4, right? This 4. But our system has taken, there is one option here. I think you can see on the screen. On the screen, D, somebody is marked 17%. D is there. That D is your D resistor. Okay, resistor is, it's your thing. You are taking it as a 4 second. You are thinking it as a 4 second. So you gave 4 instead of giving option C. But it has registered it as option D. It happens. Anyways, leave that stuff. Okay. Srinivas is trying to say something. R is equal to 6. Looking from the capacitor end, current source is open. Yes, absolutely. He has nicely written that as well. Okay. Okay, dear. As I said, we're winding up this session over here. Okay. We got a few more questions. I think let's not get into those right now. Okay. If you have anything to ask in general, you can ask. Otherwise, we're happy to end the session. Regarding this discussion or anything in general, if you want to ask, you can ask. There's something? No, dear. But one thing is clear, buzz has increased. Buzz in the market has increased. Okay, not the hype, Hype is different. It's not hype, created hype. Buzz has increased. So yes, but no extra information we have received. Remaining questions. Okay. So we got a request to show the remaining questions. I'm showing the remaining questions as well. These are actually good questions. Okay. I've already shown these questions to you. Yeah, this one. You may think that you need a calculator to solve this, but without calculator, in maybe 10 seconds or 15 seconds, you'll be able to solve this. Okay. This is an easy one. This question may take a little time. Okay. And this one also, you don't need calculator, you don't need much of time. In 20 seconds maximum, you can take 20 seconds, not even 20 seconds. I think in less than that time you can solve this question. Okay, 20 seconds you can take. This is easy. This one also, it will take less time. Okay, not calculator. This one, you guys might be thinking that you need a calculator for this just by looking at the question. In 10 seconds you can answer this one also. Okay. Anyways, these are the questions what are left. We're left with these questions. I think Andhra notification status, if you talk about, there will be a notification for sure. Okay, in Andhra, because it's been a long time in Andhra to see a notification. You call it as maybe digital assistants, you call it as a transco. So vacancies are pretty much there. Okay, it's only the election momentum will give you some notification for sure for electrical guys in Andhra. So be ready. Okay, it's not necessarily maybe right now state electricity, but gram panchayat where you got digital assistant posts are there, right? That's high possibility. Okay. Yep. Anything further? I think that's what you got. Maybe that's where answering. Okay. Like from APPS it is come. Yes. Yes, dear. In Transco, AP Transco, there are vacancies. Okay. And we got sir for Transco instrumentation parts, will there or not? For Transco instrumentation post, okay, post for instrumentation, I think not, possibly no, dear. So we got a request for power electronics tomorrow, choppers. Okay, we'll see. What is your call, guys? Is power electronics okay? So for Transco people, job, okay, I think it's addressed. If someone asks, okay, this is a good one. I always tell my students this one. Okay, it's not that I'll answer. I think my students will be answering this question. If someone asks you, what is Ohm's law? Okay, I will never say V is equal to I into R or I is equal to V by R. I would never say that. Okay, I think my students who are there, they will be answering right now. Don't say V is equal to I R. That's, maybe 10th standard student will answer this. Being undergraduate, once you graduate, an interview, if you still say V is equal to I into R or I is equal to V by R, that's not, properly correct. Okay. हाँ, digital assistant, क्या कर रहा है? Okay. I'm ready with 90% accuracy in exams like mock, etc. Very good, dear. That's what, see, Mahendra, he's always confident. I love that confidence. So you attempt TSGENCO, dear. Okay, if it comes TSGENCO appear, you check your preparedness. Power plant engineering should be included or not. It's a generation company. It's a generation company. Power plant engineering is pretty much in line with generation company. It's not, generation company, power plant engineering, not too different. Power plant engineering is a part of a generation. Okay, but that should not be included for electrical guys, because mechanical people are there, civil people are there, they will handle that. But maybe their objective of including that is, of course, though it's their subject, you should also have some basics. So maybe in that respect, they must have included that. But I don't think it's required for us, definitely, because we're anyway studying about the generation, okay, not about the strength, material strength, all these things, but electrical aspects we're talking about, we're studying that, okay. But what's wrong if you're learning these? Yeah, maybe, but I don't see it should be included. Raju is said the answer for your question. Sai Ganesh, what is Ohm's law means? Raju is my student, I think. He said J is proportional to E. That would be the answer. Sir, already signals analog there. Let them include communication also. Leaving. Yeah, that's what. Because signals is included, analog is included. If they include only communication and EDC, if they include communication part and EDC part, then I think they don't have to give post for EC people also. Electrical people can do anything, everything. Okay. Nowadays they are doing, software jobs, and they will do EC job. They will kill EC as well as mechanical civil as well. What does a flip-flop actually works? I think we'll talk about these digital logics a little while later. Okay. Flip-flop is just a state, changing a state. Okay. EDC is chemistry of analog, and gate is also deeply people are getting top 10 in, yes, that's true. Okay. Anyways, I think we had a good interaction. We didn't have a good interaction during the session when I asked you for the questions. You didn't answer. But after that, we had a nice rapport. Okay. Let me end the session, guys. Thank you for joining. Have a good time. And don't delay. Don't delay. Start learning. Keep learning. Okay. Don't waste your time. All the best. Have a good time.